Hello and welcome back to another video in the Learning to Program with Go series, and today we'll be covering anonymous functions. A prerequisite for this video would be the functions as values video, where you get to learn about how functions are basically values in Go and how we can assign functions to different variables. Anonymous functions are unnamed functions, which makes a little bit more sense now, and they can be assigned to a variable or declared inline with another function. Now to put this in perspective, let's say that we want an add function. So before you knew functions as values, we could create just a regular function called func add, and it takes in two ints, so a int and b int, and then it can return an int back to us by just doing return a plus b, right? And so we can go into our main method and just call add 1 2, and let's print out the value just to make sure everything's working as expected. So we get 3. Now we can have this as an outer function, but the magic of anonymous functions are that they are closely used with defer and concurrency statements in Go, which will also be explained in later videos, but this is just the foundation for it all. If we want to turn add into an anonymous function, we can go up into our function, our func main, which a property of an anonymous function is that it's a function within a function, and we can assign it a variable. So I can have, let's comment this out, but keep it there, and let's move the print statement down. I want to have a variable called add, and it's going to be assigned, and it's going to take in an int called a, and then another int called b, and it's going to return an int. Then we open up the braces, return a plus b, and all of a sudden our add variable now holds a function. It's just that the function is not named, and it's within another function. So I can still call my print line function that calls add. Let's run this one more time, and we get 3 printed out to the screen. Now this is really powerful stuff, and you can take this even one step further by not even assigning it to a variable. What we can do is we can remove the add here. So now we just have an anonymous func that basically just has that value as a type of look to it, saying that I am a func that takes in 2 ints, returns an int. But you might be wondering, what's the point of declaring a func right here that's not assigned to a variable? Like, how do you even call that? Well, you can go ahead and just put parentheses right after it, call 1 and 2, and it will go ahead and return to you some sort of value. So if this anonymous function returns an int to us, we can therefore assign it an int at the top. So we'll say num is equal to this anonymous function that is called, and let's go ahead and do a print line of num real quick, run it, and we get 3 printed out to us again. Recall that in a previous video we went over the slices package, and in the slices package there was a sort function. Well, right below it, the slices authors also gave us a function called sort func, where we can sort a slice with our own custom compare function. So reading this, we have a func called sort func. It's going to take in a slice that inherits like an equatable interface, which means that we can compare different elements. Then it takes in a slice called x of the s type, and then we can give it a compare function. And so if you're now more familiar with the syntax, it's a function named compare, and this function takes in a and b, which are of both type e, which is sort of generic, and then returns back an int. So that might sound a little confusing, so let's go look at it over in some code. So we need to write a compare function, and let's do it the old normal way so far. So ignoring all of what's going up in main, we're going to have a function called compare, and it has to take in 2 ints, right? So we'll have a, b, which are both int, and it returns an integer. Now, if we go ahead and call the slices package .sort func and look at some of the documentation here, we'll see that the documentation reads that it sorts the slice, blah, blah, blah. The compare function that we pass in should return a negative number when a is less than b, a positive number when a is greater than b, and 0 when a is equal to b, or a and b are incomparable in the case of a strict weak ordering. So what happens is that compare receives 2 integers, a and b, and we just have to say, is a greater than b? But since we have a third case, we must use integers to represent the 3 different cases. So negative if a is less than b, 0 if they are the same, and 1 if a is greater than b. So let's take a look at this. It's actually a really simple function. All we have to do is return a minus b. Again, if a is 10 and b is 1, a is greater than b, so then this produces a positive result, therefore means a is greater than b. So up in our sort function, let's go ahead and create a slice. So slice s is going to be a slice of ints, and it's going to hold 5, 4, 3, 1, and then 2, just to change it up a little bit. And so when we want this to be sorted, we just go ahead and call the slices package sort func. You pass in s and then the compare function to go ahead and compare everything. Then we'll print out the slice and see what it looks like. So let's clear the terminal down here and do a go run. And we see that S turned into 1, 2, 3, 4, 5. Now we don't have to keep this as a function standoff alone. We can go ahead and turn this into an anonymous function. So what we can do here is say CMP is equal to compare, right? And then pass in CMP and we're good. But that's not an anonymous function quite yet because we still have it declared below. So instead, we can go ahead and just copy this function, paste it up here, and then just fix some of the syntax that's going on. So if we're declaring like an inline function or an anonymous function, it means that we cannot have a name. So we have a func that's AB that are ints and then returns an int. And so we save this, fix the formatting. We can remove this compare down here, and the program is still going to work as intended because this function was assigned to the compare and then compare was passed as an argument. And then we can take this one step further and just putting this entire function as an argument right into the function call itself. So we remove this, and now you kind of get that more closure type look if you've worked in other languages that have closures like Swift. So we have slices.sortFunc, give an S, and then we create a new func that returns A minus B. Let's save this, confirm that it still runs correctly, and we get 1, 2, 3, 4, 5. To drive home this whole entire anonymous function business, let's actually write our own function that can take in an anonymous function or function as a value. It's going to be very similar to the sort func up above here. So we'll have func MySort, and we're only going to worry about sorting int slices. So I'm going to have an int slice called S, and then we're going to receive some compare function called CMP func, and then we pass in the function as a value here. So A and B will be integers, and this function is going to return an int. And to make this function header a little bit more clean, let's declare a type that holds this. So we'll call it CMP func type, pass in what the underlying type really is, and then copy this name and throw it down here. So now we have a little bit more of a clean header for this function that makes a little bit more sense. We can open up the braces. And so now it's time for us to implement a sorting algorithm rather than just the compare, because we're given the comparison. We know how to compare two items given the function, but now we need to like sort it. So look up your most common sorting algorithms like bubble sort or insertion sort, whatever you want it to be. But I'm just going to implement a very rudimentary bubble sort here. So how we do that is I'm going to create a for loop, which we've gone over these. So for int I is equal to 0, I is less than the length of S minus 1, I plus plus. Then we open this up and I forgot the I right there. And then we can go ahead and do for J is equal to I plus 1, and J is less than the length of S also, which we can optimize a little bit more, but I'm not going to. Then we do J plus plus. Then we have some comparison. So what we can do here is we can get a sort result, or really compare result, let's call it that. So compare result is going to be equal to CMP func, and we have to pass in the two ints and we'll get an int back. So we'll pass in S at I and then S at J, right? And then we can say if CMP result is greater than 0, which means that the element I at I, or the element that comes before J, if it's greater than it, then we need to swap it to maintain ascending order. So we can do a quick swap by saying temp is equal to S sub I, and then assign S sub I to SJ, and then say SJ is equal to temp, because temp originally held the original S sub I value. So if we go ahead and save, we should be good. And so now let's call MySort up here, given S, and then a compare function, which we need this compare function back. So we're just going to yank this and then go back to what we had. So now paste this. And so we have our function. We've already written our compare or our sort function down here. Let's go ahead, save, and run this. So go run, which I didn't print out anything. So let's do a format.println, pass in S, and we get 1, 2, 3, 4, 5 is printed back to the screen. And that's just using a very rudimentary bubble sort. I'm sure that Go's sort function probably sorts a whole lot quicker and efficiently, but this is just a simple example. All right, so now you're one step closer to mastering functions in Go. In the last video, you learned about functions as values, and then in this video you learned all about anonymous functions, how we can declare them in line, we can pass them to other functions and call them within that function. And in the next video we'll be talking about closures, which are functions that can access things outside of their scope. So if you've made it this far, I really encourage that you like and subscribe. Thank you so much for watching this video, and I'll see you in the next one.